All right, so the final thing we're going to cover in this session is how to do multi-level meta-analyses and how to do robust variance estimation. So both these techniques are largely done to control for dependent effect sizes. So one of the things I said that you can't really do in the other software that's available is control for dependent effect sizes. All right, so if we go back to our data file, we can see if we sort by study ID, for instance, all these effect sizes came from the same study. All right, so they measured each of the branches, maybe in different samples, etc. Okay, that can be a problem, right? To treat these as completely different studies. And that's what we've been doing so far. We've basically said, ignore that. Ignore the fact that they come from the same study. One of the things that does is that ends up with a smaller standard error than you should, all right? Because you've ignored that dependency between these effect sizes. All right, so it's the same if you've learned about multi-level modeling, but what you want to do is say, these 4 effect sizes come from this study, all right, and they should be more similar than 2 studies drawn at random, right? Two effect sizes drawn from the same study should be more similar than 2 effect sizes drawn at random from the 51, okay? That's because there is dependency in our effect sizes. So how do we control for that? Well, there are 2 ways of controlling for that. There's multi-level meta-analyses, and there is robust variance estimation. These 2 ways of controlling for the dependency will get you slightly different effects, but they're both effective ways of dealing with this. All right. So when you look at the research on this, they both will deal with that dependency. They will come up with slightly different estimates. Okay. I'm going to put a note on kind of the best practice summarizing from the research that's done about when to do multi-level modeling, multi-level meta-analysis, and when to do robust variance estimation. So when to apply the robust variance estimation to multi-level model. The recommendation, I think it currently is, if there are 50 studies included, then do a multi-level model, all right? If there are only a limited number of studies, or you're not particularly interested in the case level variance, robust variance estimation is preferred. Generally, I've used robust variance estimation. It's a nice, I think, simple way of dealing with it and not having to worry about it. Right? If you're not really interested in it, right? If you're not really interested in partitioning the variance within studies to between studies, and you just want to say, oh, this is a pain. It's a pain that these things come from the same study. I just want to deal with it and not even think about it. Robust variance estimation is a nice way to go. Okay, so let's run with this and run a multi-level meta-analysis and then apply robust variance estimation to that. Okay, so we're going to need a new package called a club sandwich. So install that package. All right. So we've installed it, we've loaded it. All right, let's run a multi-level meta-analysis. All right, so we're going to do, let's call it something else. Call it random effect size, random RVE, robust variance estimation model. So we want RMA, but .mv. All right, so RMA multivariate, level. Same stuff though. YI, VI. Okay. Let's do this. Let's leave out the moderator first, and then we'll add some moderators back in. So the extra thing you can give it is random, and what you're telling it is, I want 1 for study. What is this variable called? Study underscore ID. Okay, and so we need to tell it where to find the data. Okay, so basically what this random bit is saying is I want an intercept for each study ID. That is to say, I want the mean for each study. So study ID, to go back to the data, is unique for each paper. Probably not unique for each study. You can see study 1 and study 2, both the same. So unique for each paper. So we're controlling for the fact that these two studies came from the same paper, that all these effect sizes came from the same paper, and so forth. All right, so if we run this and then print the results, all right, we have our multi-level meta-analysis. Okay, so 0.12. So if we go back and just run this, just run our first ever analysis again. So forgetting all moderators. So if we run a single level multi, we get 0.0978. And if we run it as a multi-level meta-analysis, we get 1.1252. Right, so we get a slightly bigger effect when we run a multi-level meta-analysis. Right, so that's nice. We also get a slightly larger standard error, okay, as you would kind of expect, right? Because ignoring that clustering leads to an underestimation of the standard error. All right, let's apply some. But say you wanted to use the robust variance estimation procedure. It's just one extra line of code. Okay, so let's run that. Okay, the estimates should be the same. Right? The issue is not with the weighted average estimate. The issue is with the standard errors. Okay, and the standard error should change. And you can see here it's changed a minuscule amount. All right. So with robust variance estimation, you get this p-value here, slightly larger value, but they don't disagree. This is the multivariate meta-analysis, and this is applying robust variance estimation. We can do the same thing with moderators. If we run a multi-level meta-analysis, let's run with branch. All right, so pulling together a lot of what we've done, let's run a multi-level meta-analysis with the moderator of branch, re-leveling it with the reference group of management, emotion management branch, random effects a study I control for. So let's rerun that. And we can see, look how nice that is. Everything's significant. Okay, so that's nice. But what we know is there are very few studies in a lot of these categories. So with the sample size this small, right, in each of these subgroups, I suppose, you really want to use robust variance estimation, right? You're going to get extremely small errors. So let's apply the robust variance estimation. And cool. Okay, so you can see facilitation, perception, understanding are no longer significant, but emotion, intelligence, total remains significant. Okay, so how do you pull this all together? You can see that multi-level modeling and robust variance estimation will sometimes, but not always, give you different results. I've given you a reading there to help you decide whether you want to apply the robust variance estimation. But if you have a small number of studies, or if you have a small number of studies within a categorical moderator, you should apply the robust variance estimation. And so what you're reporting, you don't have to report all these steps, right? So you don't report a random meta-analysis and then a multi-level meta-analysis and then a multi-level meta-analysis with random variance estimation, right? You choose what the appropriate meta-analysis is and you report that, Okay, but you can see that those decisions can have a bearing on what you find, right? Because these are different ways of understanding the variation between the studies and within the studies, and there are different ways of accounting for that. So hopefully, whatever you choose, you can defend it, and you now have the tools to apply it in R. Anyway, best of luck.